We're going up and down, over and over, over and over. It's the same old thing. Up and down, over and under.
Dr. Levine, welcome to the show.
Thank you. I'm excited to be here.
Yeah, very excited to have you here. So the nature of your work is a huge interest of mine. And I will be completely honest. I have not had my biological age tested yet. And recently I'm like, I really need to do that, but I'm going to hold out until I get to talk to Dr. Levine to make sure that I'm going about it the right way.
Yeah. Sometimes I think people too wait till they've been on very good behavior, right? Before they do it as well.
Clean up my act a little bit. Well, hey, maybe for those who aren't familiar with the nature of your work, would you mind just telling the audience a little bit about what you do, what your focus is?
Yeah, so I run what's called the Aging Living Systems Lab at Yale, and we're really interested in kind of two things. Number one is, can we actually try and quantify the aging process? So I'm not talking about how we measure age in terms of chronological years, but can we actually measure the amount of kind of change your system or your body has undergone over time? And we think that this is important because it's predictive of things like remaining life expectancy or disease.
Yeah.
And then the other half of my lab is really interested on, is there anything you can do about this? So what drives kind of the rate at which that happens? Can you do things to slow it down? Or even some people think potentially, can you somehow revert it to some degree?
Yeah. Yeah. And I think that's why I'm so intrigued. So again, for my listeners are probably tired of hearing me say this. I'm in like my mid-30s. So I'm very much at that point in my life where I'm like, not quite as invincible as I once was. And now, laser focused on like, hey, what can I do to maintain? Right. And I think historically that would probably be like a pretty good objective. But now what's so exciting is like, whoa, is there actually an opportunity to, quote unquote, like turn back the clock a little bit? So maybe to that end, could we even, because I feel like maybe this is evolving at a kind of a rapid rate. Could we start by talking through like how you define aging?
Yeah, so I think I like to define it thinking of it from kind of the systems perspective, and first thinking about it in terms of how our bodies are just constructed to begin with. So to have a living system, especially a human, you need this very complex arrangement of everything kind of in the right order to be able to do all the amazing functional things that a human body can do. But unfortunately, you can't maintain that complexity and structure forever. And so over time, due to, a number of things, random perturbations, you slowly drift away from this optimal state. And with that, you lose functioning because your body is not really set up the way it was initially designed. So that's kind of how I think of aging. People in the field everyone has a different definition, but I like to kind of use this kind of system state change.
Yeah. Well, and now I'm going to divert off path a little bit. At what point, and maybe I imagine it's different for the individual, but at what point do our systems kind of reach like that peak optimization? And then at which point, I mentioned, I love some of the anecdotes in your book that's about to come out. When does that ball start rolling downhill? Like what is that age from chronological age for most people?
So actually, I would say science doesn't know the answer. Like when is your body at like the most optimal functioning? And it actually probably depends somewhat on the functioning. So certain things you do better earlier in life. And actually we can observe aging even as early as in the womb. So like before birth, you see some of these changes occurring. So, some things you develop over time, right? You develop your immune system over time. So this is probably at its highest kind of functional fidelity a little later, whereas your regenerative capacity may be a little earlier. So yeah, hard to say.
Yeah, no, that's a good point too. And, even thinking about athletics, more broadly, like if you're like an explosive athlete, like a sprinter, your peak could be, I don't know, mid-20s, maybe even like 30s, if you really take great care of yourself. But like strength-based athletes, they might experience the highest points in their career, like all the way into their like early 40s. So that is like a good lens, I think, to like step back and look at it through. It's like, okay, well, what are we trying to define? That makes a lot more sense. Well, and something I think that would be helpful just for the audience, what is the difference between someone's chronological age and what we would call like their biological age?
Yeah, so chronological age is what, everyone knows, right? It's the number of years, days, months that you've been alive.
Trips around the sun.
Exactly. There you go. And we put a lot of importance on this age. And we think of it, there's definitely a negative connotation, but actually it's not this chronological time that matters, but it's because it tends to be kind of correlated with what we think of your biological age, which goes back to the systems idea. It's the degree of change your body has undergone, and this is kind of a maladaptive change. So we can actually try and quantify this and actually give people what we think is a biological age. So this would just say your body looks like someone who is a given the average person that's, let's say, 50 in the population. And that number actually seems to be much more meaningful for health than knowing your chronological age.
And I guess like the next question then is, what is someone supposed to do with that information once they have it, right? Like,
yeah.
Because I think some people, there's probably, like you said, like if you're going to get your biological age tested, you probably clean your act up. There's a lot of people who are like, I don't know if I want to know. Like I had a lot of fun in my 20s. I sleep terribly. I'm stressed all the time. Like I would prefer just to not know.
Yes. Ignorance is bliss. And actually there's a lot of people who don't want to know. My argument would be that biological aging or aging in general is semi-modifiable. So we know only about maybe 10% of this is actually dictated by your genes. And yes, there's also some random chance, but a lot of it is actually dictated by our lifestyle, our environment. So for me, as someone who's maybe a little bit of a control freak, I would want to know so that I can actually take actions to improve that. Granted, there's some people, right, they don't ever want to step on the scale. They don't want to ever, have any insight on things, and that's their prerogative. But for people who actually want to take informed and actionable steps, I think this is an important thing.
Yeah. Could we dig a little bit deeper? So is that what the current science is saying, that like only 10% of our genetic makeup is responsible for, I guess, is it how we age?
Yeah. So usually people look at life expectancy. They used to think it was like 30%, but actually the most recent study, I think the most recent one's out of Calico, I think was about 10%, and that seemed fairly generous. So yeah, a lot of it is not genetics, unless you're one of these really special kind of extremely long-lived people. So the people surviving to like 110 or beyond, they probably have some genetic lottery, but the majority of us, our genes only have a slight kind of influence on our aging and lifespan.
Interesting. Yeah. I don't know if I told you this when we reached out, and lottery is a good way to put it. So on my mother's side, great grandfather lived to be over 100. And my mom has not been listening because she's not fact checked me on this. I can't remember if it's four of the siblings within that family. I think it was 4 of them lived to be over 100, and like the 5th one died in a car crash, sort of thing.
Oh, wow. Yeah.
But on my dad's side of the family, like I don't think a man has made it past like 60. Do you know what I mean? In like generations.
Yeah.
So I really don't know what I'm dealing with. I would love to think I'm going to hit that lottery, but I'm trying to prepare for the worst. So I guess, not to go negative first, but, when we start thinking about things that impact the way that we age, I guess, what are some of like the biggest detractors, or some of the most like harmful agents in the environment that kind of influence how our body ages?
So probably the most well-studied, and perhaps this is not revolutionary science, is smoking. So smoking is the one thing that,
Shocking.
People live on average 10 years shorter. And we can see it in terms of these biological age measures that smokers look substantially older.
Yeah.
So that's one. And then there's some question on, well, does air pollution have similar effects to smoking? So people who live in highly polluted areas might also experience some of the same deleterious things. And then For me, the other thing is probably a sedentary lifestyle. So if you don't move, it's probably doing a number on your health, would be my guess.
Yeah. It's just, yes, there was something interesting, and you kind of just referenced it in your book. And again, I don't, did we even talk about your new book, True Age?
Oh.
What is the launch date? I haven't written down.
May 3rd.
May 3rd.
Yeah.
Okay. So yeah, hopefully listeners can get this by the time or get the book by the time it comes out. But one thing that I read in there that really kind of made me think, it's like right now we're using science and machine learning and big data and all of these things to try and find a way to better understand how people age. But people kind of have this innate ability visually to just get a really good sense of what age someone was at a point in time. Like I think the example you gave was like if you saw your grandparent back when they were in high school, instantaneously, your brain's able to be like, oh yeah, they're probably a teenager.
Yeah.
So it's funny that like we kind of have this already built-in mechanism to kind of get a sense of like where someone might be in this aging process. And stop me if I'm putting words in your mouth or getting this wrong.
No.
But it's so interesting now that we're at a moment in time where now the data, the science, the measurement capabilities are starting to catch up to validate some of that back of the napkin math.
Yeah, exactly. Our brains are already wired to be able to kind of see aging, right? Or at least recognize it. If I ask my daughter who looks older, me or her grandmother, she would answer, hopefully she'd answer correctly. Yeah. Who knows? But yeah, I think, the exciting thing actually is that a lot of the measures we're developing too also show to be correlated with kind of estimates of facial aging. So these are all related. Although we know people can alter their facial aging, so it's not always a true reflection of what's happening under the skin. But for people who are not altering it, it can be a decent indicator of what's going on as well.
Yeah. Well, and you just mentioned like the methods of measuring aging. So, I've been doing this podcast for like 2 years. And since the very beginning, I was like, I need to get someone on to talk about telomeres because that's how we measure age today. And in reading your book, I was like, oh, wait a second. It sounds like things might have changed a little bit. Would you mind? I mean, we could even start by talking about telomeres because I think that in itself is really interesting. But maybe just more broadly, like what are kind of the available methods that we have today to try and understand biological age?
Yeah, so there's actually not an agreed upon way to estimate biological age. And I think this comes down to the idea that aging affects so many factors in our body that I always argue that you could probably create a decent aging measure from almost anything that you can measure in a human system. Just because everything kind of we know it kind of all goes wrong. Not everything goes wrong, but a lot of things go wrong with age.
Yeah.
So probably the first like really publicized aging measure, as you mentioned, was telomeres, which basically what this is every time your cell divides, the end of the chromosome gets a little bit shorter. So, it doesn't get fully copied. And once it reaches a certain length, so it becomes really short, your cells either undergo apoptosis, so they die, or they undergo this state change called senescence, where they can't divide anymore, and they actually end up being kind of hazardous because they sit around and excrete all these inflammatory markers.
Are these the zombie cells?
Yeah, the zombie cells, exactly.
Do we not like that term in the medical community? Is that for folks like me?
Yeah, there's definitely people in the senescence field who do not like the term zombie cells, but it sticks with people. So I think if you can,
I mean, look, I got a lot of stuff going on up here, and that's stuck in, and I can't remember half the things I'm doing throughout my day. But
no, exactly, zombie cells I think stick. So yeah, these cells they call them zombie cells because they're not dead, right? They won't die, and actually you can't even really kill them very easily. But they also are not fully alive because they're not dividing or kind of not doing what they were originally intended to. So people are actually with telomeres saying, oh, well, we can measure the length. So you can kind of get an estimate of how much of the shortening has occurred. And it does relate to aging. It's one of the hallmarks of aging. But I would say in terms of a measurement of aging, the way we measure it isn't great. So we take, let's say, a blood sample or a saliva sample, and you kind of average all the telomeres in all the cells in that sample, and you get just one number. And that's not that predictive of things. So we kind of test, like, first, is it correlated with age, with chronological age? And then another test is, among people the same chronological age, does it predict who's going to develop disease or who's going to die earlier? And I would say, of the different ways to estimate biological age, it's not that good in that regard.
Interesting. Yeah, I remember, I think the initial literature that I read about it, and again, this was communicating it to the general public and layman like myself. But, think about like the cap on the end of a shoelace.
Yep.
Right. And it's kind of like, and that's a good description. It's kind of like this.
That's the one that everyone used. Yeah.
Yeah. And I was like, okay, see that I can work with. So telomeres today, like it sounds like they play a role, but not necessarily a great predictor of biological age, or I guess, like, to your point, is it more about like risk of disease or death? Well,
yeah. So a lot of this is kind of, we assess what's called construct validity of a biological age measure because there's no ground truth. So we don't have a good way to say, oh, did we predict it really well? Because we have nothing to really say. So what we ask is, well, does it relate to things that you would expect some, biological age to relate to? And so, yeah, it's who's most at risk of age-related diseases, who, we predict things like remaining life expectancy, functional decline, cognitive decline, these kinds of things.
Got it. So did telomeres and telomere length and telomere measurement, does that still play a role in some of these methods for trying to determine someone's biological age, or have we now moved on to other methods and, we're not even pulling telomeres into the conversation any longer?
I would say 90% of the field has moved on. Some people still use them and measure them. Most people are not using them.
Interesting. Okay. So what are we using now?
So I kind of like to think of it in terms of three kind of hierarchical categories. So you can start at kind of like the most basic, easiest thing to measure, which people just do like a kind of deficit accumulation. So they give you like a number of things and they say, how many of these problems do you have? How many, of these specific diseases have you been diagnosed with? Do you have impairments when it comes to these different abilities? And you kind of just add this up. And you get what some people have called like this frailty index score or deficit accumulation score. So that's like the most basic at home, easy thing to do.
I can try and link to it too if people are listening. Yeah.
So this little test, kind of like those magazine quizzes. I have one of these in the book, so you can find out your deficit accumulation score.
Perfect. A nice little Sunday reading.
Yeah, exactly. That and your zodiac. Fine.
Yeah, exactly.
So that's the most basic. But the issue with that is for most people who are younger and haven't accumulated anything, there's like this floor effect, right? You can't really differentiate people who have yet to accumulate disease. And actually we want to catch people before they get diseases.
Right.
So that's the goal. So then that's where there's kind of two other types of methods that come in. So one is you can use just a basic lab test that you would get if you went and visited your doctor. But unlike your doctor who kind of looks at one at a time and says, oh, you've passed this magic threshold that says you're in the risk category or not, what we do is we use it on a spectrum and combine it into kind of this overall system score. And this one we've called phenotypic age. And again, it is predictive of all these things that we'd expect it to be. And then finally, maybe the most complicated one is this thing called epigenetic age. So basically what that is we're looking at something called DNA methylation. So when we look at it's not a change in your sequence, so A, C, G, and T, but it's this chemical tag that you get to the C's when they're next to a G. And this kind of just tells the cell which parts of the genome are accessible to be used and generate these proteins versus which they're not accessing. They're kind of repressed. So when you have the methylation in a region, that part of the genome's essentially shut off.
And methylation being a sign of aging?
So not necessarily an increase. So every cell has a specific pattern of this methylation. So it's
Okay.
Epigenetics is actually how you get a skin cell to be different from a brain cell, even though they have the exact same genome. So they use different parts of the genome to create their phenotype, essentially.
So they're expressing different. Okay. Got
Yeah,
it.
exactly. Different factors. But the problem is that I like to think of it as the operating system of the cell. It tells the cell how to behave, what to do,
I like
what to
that.
look
Okay.
like. Yeah, but it becomes a little bit messed up. The system, again, gets messed up with age. So we can measure the pattern of where these methyl tags are in your genome. And from that, combine that information to give you have, the pattern of someone who's 30 years old or 50 years old or whatever it may be.
Interesting. So, as I kind of listen to hear you describe, how things degrade over age, is it almost more important for an individual? And I guess this, this leads back to like, why track it? Is it more important for a person to establish a baseline for themselves at, whatever given moment in time, and then be able to understand how that's changing over time and use that as like maybe, I don't want to say like a more accurate indicator, but maybe a really important indicator that helps you understand if you're making progress or maintaining?
Yeah, so we don't have really good studies on kind of this longitudinal tracking,
Okay.
but we think that this kind of continuous, like how well you're doing over time, is probably more important than your score on any given day. And again, it comes back to more this rate of increase. So are you
Okay.
increasing in biological age at the same rate at which you're increasing in chronological age? And as you can imagine, you want to be accumulating fewer years of biological age for every year of chronological age.
Right. What is the, just out of curiosity, what is like the biggest delta that you've seen between someone's chronological age and their biological age? I guess it'd vary by
Yeah.
test, but.
Yeah, exactly. I don't know what the biggest one is, because I think sometimes we think, sometimes you can get these really crazy outliers and, probably a few decades, but whether
Really?
that's true, most people, that's not the case. So I think the standard deviation, so most people fall within plus or minus 5 years of their chronological age.
Okay.
And then, yeah, I think it's more likely to see people on the higher, so looking older than they actually are,
Yeah.
versus like very young predicted people.
The guy who helps us with some of the service around the house was just talking about one of the guys who owns this business. He's like, yeah, man, he looks terrible. He looks 20 years older than. I was like, well, yes, but I was like,
Yeah.
let me get a biological age test on this guy.
Yeah, exactly.
That's interesting. Okay. And so, today, I guess, and I think you already said as much, like we don't necessarily have like a perfect measure for biological age today. But based on where we are, like you still feel like it's a valid metric to start tracking. And if so, like, do you have any recommendations? Like, what should someone look for when they start to assess all the companies that are springing out of the ground offering age testing?
Yeah, so I think we're going to continue to improve these, and we're not, we don't have the final versions yet, but the ones we do have do kind of check off these few things that I think are really critical.
Okay.
So again, they correlate quite strongly with age. So, often 0.9 correlation with age. But to me, more important is that kind of discordance between what we're predicting your age at and what it actually, your chronological age is, has biological meaning. So as I said, it's predictive of all the things we would expect biological age to be predictive of. And then the other thing that we have been working really hard on, and actually this is important when evaluating different tests, is kind of the reliability. So if I were to take the same test twice in the same day, would I get the same score? So old versions of these epigenetic tests actually were really bad on this when it came to this reliability. You could get scores of 5 or 10 years difference, even from the same exact sample, just split in half.
Interesting.
Yeah, so this is a problem. We actually developed an algorithm that removes all of this technical noise. And I only know of one company, and I will just say that I had some affiliation with them in the past. So, I will disclose there's a little conflict of interest. I don't get paid by them anymore, or if people take the test, but that actually implements this new way to remove this kind of random noise from the score.
Okay. Are you allowed to share who that is? I mean, I understand.
Yeah, I'm happy. Yeah, so it's Elysium Health. The test is fairly expensive. So I think the other thing too is if I tell people, if you have a recent lab test from your doctor, this phenotypic age based on those measures is freely available. So there's actually people have implemented Excel spreadsheets where you can just put in your numbers and get out something. So that might be more kind of reasonable thing for people to do, more continuously, because it's not costing them $500 each time they do it.
Yeah, it's like the cost of like a lab test, right? Going to Quest Labs or okay.
Yep.
And if we can get those listening to start, paying attention to their biological age, any recommendations on like how frequently someone should be tracking that? Is this sort of thing like, hey, every year on your birthday, take a swab sample and mail it in? Or is it like, no, there's benefit in doing this monthly and seeing how things are evolving over time? Like, I guess how quickly could a change show up in a test?
Yeah, so I think this is the hard thing we don't know now, because again, the science that these are built on are usually one or two times, people got tested one or two times and we look at whether they predict things. And only now with kind of the more consumer facing tests are people actually implementing them at kind of an N=1 level, so an individual level. The one thing I would say is to not put so much weight into any single test, because you can do things that might artificially change it. But then the question is, can you maintain that change? So I would imagine if you did a 5-day fast, you would see a change because your body's responding to these different things you're doing. But then are you going to maintain that over, months and months? So yeah, it's kind of hard to say. I would say, if you're doing a lot of stuff, maybe measure more frequently. If you're kind of doing what most of us are doing and we have our routine, probably once a year, once every 6 months, like you would do a normal trip to your primary care physician.
Got it. Well, and you brought up fasting. What are the sorts of things that do, like, let's say someone, regardless, they get back, they do some sort of biological age test and they're like, like, I'm not very happy with the result. I would like to make a positive change. What are the sorts of things that someone could start to do or change within their environment that would show up? Maybe positive is not even the right word, but would make a positive impact or reduce their biological age over time?
Yeah, so I will just start with a caveat. It's probably different for every person, so it's kind of hard to say. I know this is always the issue, right? It's more complicated than we wish it was. But definitely the things that I think most of us know, right? So exercise is probably a big one. So try and maintain, a fairly moderate level of physical activity. If you can do a higher, that's probably better. Diet is a big one. Actually, I was part of a study looking at what's called the fasting mimicking diet. So this is this 5-day diet that Validity came up with.
I want to talk to you about that. Yeah.
Okay.
We're going to put a pin in that. Go ahead. But okay. I want to make sure I come back to it.
Yeah. So, there are these different dietary interventions that you can do probably that will affect it. But again, it's making sure that you're not just doing something and seeing a change right away, but actually seeing this maintained change. Other things are, try to get better sleep quality, quantity, most of the basic lifestyle factors that we associate with healthy kind of lifestyle.
Yeah. It's so funny because it's like, I would love for there to be some like, oh yeah, you need to do deep cryotherapy 3 times a week. I need to do fasting once a month. Like, it's always like it for whatever reason. And I swear it doesn't matter who I'm talking to. They're like, you should probably eat better. You should try and sleep better. And you know what I mean? Work out a little bit. Like it's
boring right now.
No, but it's great though, because I think hopefully that's exciting to people. Because, it's like the thing that was exciting to me is when you said like, I guess the rate at which we age or our life expectancy is only determined by 10% of our genetics. That to me says like, look, you actually have a lot, again, a control freak. You have a huge opportunity to make a positive impact based on like the things that you choose to do, like lifestyle factors, environment. So I would hope that would be encouraging for people to hear that it's like, these are things that you can do today. You don't have to drop a ton of money. You could start making these positive changes, the second you stop listening to this podcast.
Yeah. And I think too, now as these measures get better and better, actually get real-time feedback on hopefully how they're affecting you too, right? Because I think otherwise, especially young people, right? We do these things, we're like, is that really benefiting me? Is that worth my, 40-minute investment every day? And I think if you can actually see what you're getting back, hopefully that'll help keep people motivated.
Yeah. Well, and for you, I mean, you're like at the heart of this. In addition to biological aging, I guess, like, what else are you interested in tracking to make sure that you're keeping yourself on track, or I guess that, the efforts that you're putting in are worthwhile?
Yeah. I mean, I mainly don't track other things. Well, so I track my physical activity.
Okay.
I was tracking my sleep, but then kind of fell off that bandwagon. And I've gone through stages of tracking what I'm eating, but again, have not done that rigorously. So probably my physical activity, and I mean, I have an Apple Watch, so every day kind of keeping track of that.
What are your thoughts on, right now? I mean, it's always tough, especially when you start talking about like supplements, nutrition. Like, well, actually, let's talk about the diet for a minute. I'm very interested in the role fasting plays in improving health span, improving longevity. And it sounds like you had a partnership with Dr. Longo. Are you seeing measurable results and positive impact from those who implement some sort of fasting protocol in their life, or specific protocols and not others?
Yeah. So the only one we tested is this fasting mimicking diet, which is this 5-day protocol that Walter Longo came up with.
Yeah.
And the paper's not published yet. It's almost published. So I feel like I can feel somewhat confident talking about it. And I talk about it in the book. But for this, we do see a quote decline in the biological age measure here. Here we're using the one based on the general lab tests. And to me, the more exciting thing was that you didn't just see a decline. So people underwent 3 cycles of this 5-day fast with like a month gap, I think, in between each one.
My wife has done this now. Yeah.
Oh,
so
yeah.
I'm dialed in. Not me personally, because I don't know if my marriage would survive.
Yeah. Not the easiest one. I've done it. Yeah, you need some willpower in there.
Yeah. I will do it someday. I promise. I've promised my wife I will do it. Yeah.
There you go. So yeah, you do get this decline in biological age. But for me, the more exciting thing was we measured them, I believe it was 5 months after, and they'd returned to their normal diet. We didn't ask them to do anything else. And we still saw not the same degree of decline, but it was still a maintained decline in the biological age.
Interesting. And so what do we attribute that to?
So I think we don't know the exact mechanisms. I think some people have some hypotheses, or they say, oh, it's activating the same pathways that something like caloric restriction might activate. But I think it's probably, again, more complex than we want. And we don't truly know what it is about this that's kind of giving us this benefit. We think it's this idea of hormesis. So these mild stressors can kind of make your body more resilient over time. But how that happens, we don't know.
Yeah, I wanted to ask you about that, because I always think that's so interesting. It's like this fine line that you need to walk. It's like, on the one hand, I suppose a mild stressor, as you put it, can actually make you more resilient. However, chronic stress can age you faster. So, and this might be an obvious question, so if it is, we could skip over it. But what is happening in the body that a mild stressor can actually help? Like, as you said, make someone more resilient, or hopefully for the purposes of this podcast, right? Like decrease your biological age.
Yeah. So again, I think we don't fully know what's happening in your body in response to this. I mean, even exercise, which people have studied for decades, we don't know exactly how exercise is actually conferring this benefit that we usually see to health. Probably because it's doing tons of different things. It's an intervention that's not targeting one gene or one path. Your whole body is having to respond and kind of build resilience and almost evolve in response to these stressors.
Right. Yeah. It's like your cardiovascular system. It's,
Yeah.
everything is getting hit.
Everything.
Okay. That makes sense. Well, and what do you think about, so right now I feel like what's very in vogue is, supplements. So
Mhm.
there's like NMN, there's resveratrol, there is, I don't know if you call metformin a supplement. I think it's an actual, prescription
Yeah.
drug. But what is kind of like the aging communities, and when I say aging, I'm speaking more to like the actual scientists doing the research.
Yep.
What is kind of the thought there on where all of that stands and what we know about it and how beneficial it can be?
I would say, like most things in science, there's absolutely no agreement, and people argue about this all the time.
Got it.
I will say we don't have very good data that any of these are truly beneficial. We don't have data on the contrary. So I'm not saying we have data that they're not helpful or that they're deleterious, but there's not substantial enough data that, I would go out and recommend it to anyone in particular. And again, like everything, it probably depends on you whether you'll actually benefit from any one of these things. So
Got it.
my guess with metformin or something like that is that certain people will have more benefits than others from that. But again, that's theory. I don't know this for sure, and we'll have to wait for these clinical trials to actually pan out.
Right. So, for you, and again, like for people listening, I really enjoyed the book. Like I said, I'm about halfway through it. So I'm sure there's a lot of these questions like, this guy didn't read the end of the book because she already answers that. But, for you, I guess, obviously you work in a very interesting field, and beyond just wanting to kind of share your research, like what was the intention behind writing this book?
If I'm going to be brutally honest, I did not have the idea to write this book.
You were tapped by the powers that be. I see.
Exactly. So I think I did an interview or some segment on a CNN thing, and they thought, you should expand this. And CNN didn't say this, but my agent actually approached me and said, you should actually make a whole book out of this. And at the time I thought, okay, why not? And then that's how it came to be.
Well, it's such like a fascinating, I'm going to call it a space, but it's, I think what excites me the most about it is, there's all of these things that you try and incorporate into your life to kind of either like optimize your health or, give yourself the best chance to improve your long-term health span. Cause I think, a lot of people they want to live a long time, but they don't want to live a long time if it means the last 20, 30 years are spent like sick, incapacitated. Right. So it's like, look, for me, and actually maybe we can talk about this a little bit too. I've become more aware of the fact that the big light bulb that went off was when my own father passed. I think, for a number of reasons, like it shook me, but I think something in my brain was just like, we got to get things dialed in. It's like, I don't want to have my kids watch me go through that at a young age. Right. Or to the extent that I can control it, I want to be here in like the best possible quote unquote shape that I can possibly be. And so I think the thought that now we can start to have some sort of quantifiable data to give you feedback. So like, hey, what you're doing is working, or it's like, hey, like it might not be 100% an accurate representation in terms of how we'd like to think about it, but there might be something concerning here that we need to address. Like, I think that data point is like really exciting. Well, and if you don't mind, like I was fascinated to hear that your dad was like, it sounds like a pretty interesting person, if you don't mind talking about him.
Yeah, I mean, I think my family, we always joke that, they could do another Forrest Gump iteration, but with his life, because he has like every interesting thing he did. So yeah, he's kind of the reason I got interested in aging, because when I was born, I think he was 54 years old.
Okay.
So I had a much older father than any of my friends did.
And are you the oldest, or do you have siblings?
And I'm the oldest. I have half siblings that are older, but I'm the oldest. I have one younger sister who's 2.5 years younger than I am.
Got it. Okay.
Yeah. So I feel like I was just aware of this whole concept of aging from a very young age, because I think I was worried about it, right? I worried about his health, whether he'd be around to see things. And he had been a really amazing athlete when he was younger. So he played football and baseball in college and was actually supposed to be played baseball professionally, but had a career-ending injury.
And at
But also,
USC, right? Like, I mean,
yeah,
when we
he
say
was at
college,
USC.
yeah, we're
Yeah,
not
he played
talking like
football at USC.
Southwest Alabama State or something. Yeah,
Yep.
we're talking, yeah, pretty cool.
Yeah, fight on. No. So yeah, so I mean, I even like could, like we talked about before, visually see, when I was young, he could beat me in track any day of the week. But as I got a little older and he got older as well, like I could just see his kind of loss of physical ability. And it was something I think that really he was very aware of, and it bothered him. And yeah, I was always worried about it and worried about his health. So
yeah. Well, and I think too, for people who, a lot of the joy that they get out of life is being active, or, performing at a high level and whatever that is. When you start to see signs of that decline, it's really concerning. For me, the big thing was I'm in sales, when I'm not doing this. Like I work in the technology field. So everything, I'm like, whatever I learned yesterday is probably out of date tomorrow. And so it's like, but like, so being very like sharp and being able to communicate and like have really quick word recall is like critical to what I do. And when I started, being like, oh, I can't quite grab that word. Like I can't get that to the forefront of my head. Like, what is that? I was like, oh my God, like what is going on? And that's what kind of put me down this path of, all right, we need to get things dialed in.
Yeah.
But yeah, so it's like for people, I think, who live where they're constantly pushing themselves, again, kind of that being at the top of the hill when you feel like that ball's starting to roll down the other way. Oof, it's a little concerning.
Yeah, I feel like when we're young, right, we think we're invincible. It's like, oh, I can do this because, I can go out and party tonight because I'm fine. I don't feel it, or yeah, exactly. All these things. And then you get to a point where like, oh no, I can actually see or feel these changes. I need to kind of pay attention and see if there's anything I can do about it. I mean, some people don't.
Yeah.
Some people are like, well, it's part of life. But I think a lot of us, we don't want to, go quietly.
No. Well, let me ask you this, in your opinion, I guess, there's probably gonna be two answers here. Like, what does like the broader community say? And I guess they're all arguing, so we can skip that one. But do you think that there's a finite limit on lifespan, or do you think that we've seen, enough in recent years that there might be hope that you could, quote unquote, like cure aging?
So my hypothesis is, and again, this isn't based on great data because right now I think no one really knows, and it's all speculation. I would imagine right now there's probably a limit to human lifespan. I think people estimate like 120 years. I don't think that necessarily has to always be the case. So, human endeavors, like we've discovered things that humans shouldn't be able to do, right? Fly. I mean, we can't personally fly. Sure. But yeah, all these different things, right, that we've kind of evolved even beyond our initial capacity. So that's not to say that there could not be a tremendous breakthrough in the field that could allow us to surpass that potential upper limit. Yeah. Whether humans could eventually completely stop aging, I think I'm a little less optimistic about. Because it goes back again to my definition of aging, that it's this, shift away from this state. And I would say, I don't think it's ever possible to truly halt and like freeze your system in time, because it's constantly dynamic and, so it can't not ever change. Right. And I don't think it's truly possible to fully reverse back to an initial state. You could reverse back to something that might look like a version of that, but I think you'll always be, quote, changing in some degree. And so I'm leaving it open to what that means in terms of lifespan limits. But yeah.
Do you think there's more opportunity in improving health span versus just straight longevity? Like, hey, we're going to eke out another 20 years. But
yeah, I think that's, I mean, I am kind of on the perspective that that's where the science should be focused.
Mm.
I mean, I think if you asked most people, would you be happy to live to 110, but in really good health? So, you
Yeah.
know, when you're 80, you feel like the person today does when they're 50. I think most people would love that. And
Yeah.
to say, oh, you can make it to 100 or 110 with no disease or major cognitive impairment or physical
Right.
impairment. And I think, again, that might be more doable, especially for there's a large sector of the population that doesn't even make it to even median life expectancy, let
Yeah.
alone past that. So figuring out how to just get those people, you know, expand their health span and lifespan, I think we don't talk enough about. We only talk about kind of that maximum upper limit too much. So
That's true. And am I remembering, has the lifespan in America actually been on the decline
yeah, I think the
in recent
most
years?
recent years they've shown that we're actually reverting to some degree.
Crazy.
Yeah.
It's just so interesting. I talk about this with Sonia, my wife, sometimes. It's like, as things get easier, we tend to get away from the things that like we have to do. You know what I mean? It's kind of like once a luxury becomes just a part of your daily life, it's actually detrimental in the long run. You know?
Yeah.
It's like, hey, you don't have to like toil outside all day and like hunt or do everything with physical labor. Like you can actually, you know, you can work in a nice, comfortable, air conditioned office. You can sit in a chair. You're like, amazing. That's a huge improvement over what I've been doing. It's like, yeah, but if you do that for long enough, it's like that'll actually take years off your life because now you're not functioning. You're not using your body the way that it was meant to.
Yeah, it's funny. I feel like now we have to force ourselves to be active, whereas
It's
you know
crazy.
our ancestors, it was just that was the way of life. I always I love the animated movie WALL-E, where they've all evolved to just float around in these chairs, and I hope that's not in our future. But
I know, but it's scary. It does feel like you're trending that way a little bit. My kids got a kick out of it. Another one in that vein is Idiocracy. I mean, that's
exactly.
I don't know if people have seen that. That one has some scary true predictions. But yeah, so you know, it's this balance of trying to understand like, hey, what is available to us that technology has to offer, but then also it's like you got to get back to like this primitive state a little bit and like do what you like evolved to do. It's a really, really interesting balance to try and strike.
Yeah, absolutely. You have to push your body a little bit out of its comfort zone.
Yeah. Well, and I guess maybe we can kind of end on this thread. You know, in addition to your own work, you know, is there anything happening right now that is really exciting to you? And it could be specific to understanding aging. It could be in a related field. Like, is there something going on that you think is really interesting and could be really impactful?
Yeah, so actually it intersects a lot with stuff that we work on. And actually, I switched focus to actually work a lot on this thing. So this idea of epigenetic reprogramming. And it kind of goes back to, you know, when I describe what an epigenetic age is. So again, you know, every cell type in your body has a different epigenetic profile or operating system. So what someone named Shinya Yamanaka discovered, I think it was in 2007, is that
I think I just read about this. Yeah.
Oh yeah, you can express these 4 genes that are normally expressed during development. You can actually take even an old skin cell and make it like an embryonic stem cell. So it looks like an embryonic stem cell, which is that was revolutionary for a few reasons. But the reason people in aging got so excited is because even before the skin cell becoming a stem cell, it seems to reverse its aging profile to some degree. So it kind of goes through the state where it's an old skin cell, then a young skin cell, and then you can push it back to being, you know, not a skin cell anymore. But aging researchers are really excited about this idea of, can we just push different cells into these younger states and actually like change, you know, what might have been older, kind of dysregulated epigenome back into more pristine functional state.
See, and I'm over here just telling people to work out a little bit, sleep, and then you're
you're
withholding it. They don't have to. We're just going to reprogram all their cells and take 20 years off their life.
If we can figure out, So this is the issue. This is the issue. We can do it in a dish quite easily. I mean, fairly easily. We can kind of do it in a mouse. Again, it's a transgenic mouse, so its genes are manipulated so we can induce these factors to be expressed. Neither of those are that beneficial for thinking about how you would do this in a human, and especially how you would target this to different cell types in the body, whether they'd have different amounts of dosing that you'd want. So there's still a lot of hurdles. So I would say people should go exercise and eat well and not hold out for this, because we might not actually figure out. I'm optimistic we'll figure out something, but it's possible we won't figure out how to do this.
Very cool.
And
so you're shifting some of your focus to this work?
Yeah, so we're really interested in kind of linking the epigenetic changes we have actually observed in making these biological age estimates, to actually figuring out how they're integrated into this and how this intersects, whether it's acting on the same things and biologically what's doing that, and actually whether you can find better factors, because these were discovered for the whole idea of making stem cells, but we don't want to, turn your entire body into a bunch of stem cells. You want liver cells and skin cells. So can you find factors that are just going to operate on this kind of aging reversal, if you call it reversal? Yeah.
Do you subscribe to this thought of like longevity escape velocity? Have you heard that?
Yes, I have heard it.
I mean, okay.
I'm agnostic on it right now. I think until we can have the big one breakthrough, I don't. I mean, the concept makes sense to me, right? You basically, there's a breakthrough and it'll get you, to live long enough till the next breakthrough. And you kind of just keep riding this, and the idea that you'll live substantially longer because you make it to each next breakthrough. I would say we need the first one before I believe that this is anywhere in our future.
Okay, we'll get back to work, because we need to start converting these the epigenetic cells. I'm not even gonna try and repeat.
It's fine.
Well, awesome. This was so interesting, and as I said, the book is great. I can't wait to finish it. So maybe to that end, for people who want to know more about your work, in addition to the book, like where can I direct them?
So I have, like everyone, I'm on social media. So Twitter, Instagram. I think I have a Facebook page, although it's basically just redundant on my Instagram. Yeah. So, and my lab also has a website. I think it's just Morgan Levine Lab, that discusses a little bit more of the science that we're working on.
Awesome. Well, we'll link to all of that. And again, folks, go out and get the book, True Age, Cutting Edge Research to Help Turn Back the Clock. Thank you so much. This is such a great conversation. And if you're up for it, we'd love to have you back at some point in the future.
Absolutely. Thanks, Ken.